This assessment asks us to examine reaction A, B, and C and tell which would benefit most from using, or which would benefit at all from running the reaction in micelles. What we first notice about reaction A is it's the reaction of a gas. Gases aren't going to really matter. They're not going to be dissolved preferentially in micelles, but more than that, the reagent, the reactant that we're starting with, this diacid, is a relatively polar molecule that would already be soluble in water. So we don't need micelles to help dissolve H2 and the relatively polar reactant. So micelle technology won't work that great there. In reaction B, we have two nonpolar molecules, and so nonpolar molecules aren't likely to dissolve in water, so the micelle can actually help those. By creating that nonpolar core, we can dissolve the nonpolar organic reagents and help them come together. So micellar technology could be helpful in B. In C, we have, again, two nonpolar reagents, and in this case, the reagents are slightly more reactive than the ones that we had in B. And so micellar technology is probably going to work best for this one, given that we're bringing slightly more reactive species along with a metal catalyst, getting those to come together within the micelle. So A, running it in a micelle won't help much. B will help. C will help, and probably for C, it would be most useful.